Hello everyone, you are welcome to Computer Networks and Data Communications. I've noted that you have done well, a number of you, in terms of reading, and that by now you should have answered the assignment given to you. So today we want to discuss IP addresses and subnet masks. You were also looking at IP address in your assignment and you did quite extensive research, so you find this information very familiar, and it will assist you to get a full understanding of what you have been working on so far. So let's get started. We want to begin by identifying what an IP address is. So what is an IP address? Well, simply put, an IP address is a very unique address that identifies a device on the internet or on the local area network. So any device must have a unique identity on the internet, whether it's a smartphone, it's a laptop, it's a printer, provided it's a networking tool, a networking device. It should have its own unique identity, and so that unique identity is what is referred to as an IP address. So your phone may have other identifying features, but for the purpose of communication via internet, it must be assigned a unique address, a unique character. And so that is basically our interest today. We want to look at that particular address that is assigned to each particular device. It could be a switch, a router, a hub. Any networking device must have its own unique identity that cannot be shared on the network. IP address stands for Internet Protocol, and we're saying that this is just a set of rules governing the format within which data is going to be sent via the internet or local network. So for data to be moved from one point to another, from one device to another, it must observe this Internet Protocol format, and that's why a very unique IP address is important. Now, talking of an IP address, essentially this address is basically a string of decimal numbers separated by periods. By periods we mean a full stop for better understanding. So let's look at an example. This is an example of a typical IP address. It's a 192.128.1.1. So the dot there are referred to as the periods, and you have seen that this string has been divided into four. So there is the first 192, then 128.1.1. So those are actually divided into that, and that's a string. These are decimals. These are values that you and me will be interacting with. However, you recall in first year when we're talking about data representation, we learned that computers do not fully use these numbers like decimal numbers. It actually uses binary. You remember that? Yeah. So now, if you are to express an IP address in terms of binary, then we are simply saying it's actually a 32-bit digits divided into four parts, and these four parts are called octet. Each octet contains 8 binary digits. So if you look at that value, that IP address on top there, the 192, that is one octet. 128 is another octet. 1 is another octet, and another one there is another octet. So those are 4 octets, meaning that if you were to pick the 4 octets, and then we are saying each octet contains 8 binary digits, or 8 bits, then the total will come to 32. That's basically simple maths. 8 times 4, you get 32 bits. So what we mean there, allow me to illustrate it this way. If you are to write that IP address, the one on top, in binary, that the language that the machine will be able to understand, then that is what you will represent this IP address. This IP address is now represented in binary format. It has been converted from decimal to a binary. So 192 is going to be written as 11000000. Remember, these must be 8 bits. Another 8 bit, that 128 is there, the 8 bit, and then we have all that. So basically that's how it is. Then let's look at this in a bit more detail. So we want to build our understanding by looking at what we did previously, the decimal and binary. Now I have this chart with me. I'm sure you recall that you had this chart that you were using, and this is the chart that was helping you to quickly convert from binary to decimal. Now when you talk about converting from binary to decimal, you are looking at this binary here. Remember, this is 1 octet. So 1 octet will have 8 digits, and these are the 8 digits. When all the octet are turned on, so when all the bits are turned on in that particular octet, it will be 1 1 1 1 1. When they are turned off, it will be 0 0 0 0 0 0. Okay. Down here, I've put some switches. When you look at the switch, I don't know if you've ever wondered why the 1 is there and why the 0 is there. Basically, it's the same concept that whenever current is flowing through a particular circuit, it will be 1. The status will be 1, and when there is no current flowing, the status will be 0. So when you press down that button like it is turned on. When you push down to the other end to 0, then it becomes off. Then common switches on our machines are like the one in the middle there. That symbol there is explained at the end. It actually has that 0 and the 1. Again, it is a binary because you use the same button to switch on, and that same button you press to switch off. So when you press it, you depress it. If it were off, it will turn on. If it is on, you depress it, it turns off. So there is an aspect of a binary even on that button. So an IP address of 192.168.1.1, its first octet 192. Let's look at our chart there. If we want to look at 192, you convert 192 into a binary. So what are you going to do? You notice that here, beginning from left to right, you have 128. That chart will never change. What will be changing are the bits that are at the bottom, the ones in red. The ones in green are representing decimals. The one in red are representing a binary. So if you are to convert 192 into binary, then you are going to turn on 128 there. That one will remain on, and then 64 will also remain on, 32 will also remain on, 16 also remain on, because we are adding 128 plus 64 plus 32 plus 16, and then that will come to about okay, we're still missing some 192. So 192 is 128 plus 64, that's 192. So you're just going to turn on one on 128 and the other one on 64. So that's the explanation that I was trying to put up there. So when you turn on a binary below 128 and 64, then you're going to have 192 in binary, sorry, in decimal, but in binary it will be 1100000. So that's the expression there. So you turn that one on, you turn that one on, the rest of them you turn them off, so that you have that binary. So that binary there represents 192 in that IP address. When all the bits are turned on in this particular octet, then it will actually be like that. And when it is like that, then it means this particular octet is making use of all the bits are taken up, and so it is a 255. No, so to get a 255, you simply have to add those in green there, must be added up because those are the decimals. If all of them are turned on, then you're adding everything. But where it is 10-0, you don't add that. No wonder 192 is actually just looking at 128 and 164. I'm just trying to help you recap on what you did in first year. Now let's dive into the lesson for today. So we want to look at subnet masks and CIDR notation. CIDR stands for classless interdomain routing. Now, how would you determine a subnet mask given an IP address? Let's say we are given an IP address of 192.168.1.5/24. That /24, ladies and gentlemen, is a CIDR, the classless interdomain routing. The classless interdomain routing tells a network engineer or a network administrator how many bits in the subnet mask are turned on. So if we were to express that, then we are saying there are supposed to be 24 bits that will be turned on in our subnet mask. Right, so let's pick a subnet mask like that. So we are counting. It's a 32 bit. So now we are told 24 bits of that 34 are turned on. 24 bits are turned on of that 32 bit. So it means that the first octet and the second octet and the third octet are all turned on because 8 plus 8 plus 8 will add up to 24. Alright, yes. So that is where the 24, the /24 is coming from when those are turned on. So if that's the case, then our subnet mask will be written as 255.255.255.0. Remember the selected area there. When I did mention on the previous slide that when the entire octet is turned on, then it translates into a 255.255. Sorry, it translates into a 255, not the dot, please. It translates into a 255 because all the bits here, if we have to just roll back, are going to be used. The decimals there, you're going to add up all the decimals and then it will add up to the 255 that is there. All right, so let's continue. So I want to emphasize once again, as you can see there, the 255.255.255 is actually written in binary as 1111.111. Okay, those are 8 bits, 8 bits, 8 bits, and the last octet is actually 0. First octet, second octet, third octet are all turned on, making a 255.255.255.0 because the last octet is all zeros. And that's exactly what is represented right there at the bottom. Okay, I hope you're following. Let's move on. Now here we are. We want to find the CIDR for this subnet mask. So now it's the opposite. There we were given the IP address. Now we have the subnet mask. So we want to determine the classless interdomain routing from this subnet mask. So a subnet mask is 255.255.248.0. So when you look at this, your focus and my focus must be on the third octet because the first octet we know all the ones are turned on. The second octet, all the ones are turned on. But now on the third octet, it's a 248. So not all octets are turned on. So we want to see how many bits are supposed to be used in this network ID. How many are turned on? So to help us, we will go back to our chart. So when we look at our chart here, focusing on the third octet, let's bring the third octet and write that octet, convert it into binary and see what we are going to get. So when we convert that into binary, the 248, then we are going to have a binary digit which is 1111100. If you add up the ones in red, if you add 128, 64, 32, 16, and 8, you are getting exactly 148. So you can see the number of bits that are turned on in the third octet that are 1, 2, 3, 4, 5. So if these 5 are the ones that are turned on, then what is our CIDR? Remember that in our subnet mask, the 255.255, the first 2 octets are all turned on. That means it's 8 bits, 8 bits. Now in the third octet, that's where we have just, I think, 5 bits turned on. So then our CIDR is going to be /21, because we're talking about 8 bits in the first octet plus 8 bits in the second octet, then plus 5 bits in the third octet. So it is 8 plus 8, which is 16. 16 plus 1, 2, 3, 4, 5. So 16, 17, 18, 19, 20, 21. And that's why we have a /21 there. So our CIDR, the classless interdomain routing for this particular subnet mask, is 21, a /21. Well, I hope it's making sense, but anyway, let's move and look at another example. Maybe we'll get a lot of guidance and sense from there. Now, something different is we want to look at the network ID. How do you determine a network ID given a subnet mask and a network ID or an IP address? So here we want to look at, want to determine a network ID for that IP address given this subnet mask. So we are using the same subnet mask that we had. Now we have given 2 things here. We have the network, the IP address, which is 192.168.40.55. Now we want to use the subnet mask to determine the network ID. The network ID is the address that will be assigned to a particular device, which is going to be a fixed figure. So how do we go about it? Well, the first thing is we need to look at the subnet mask. Our subnet mask is a 255.255. When you look at our network IP address there, it means that the first octet of our IP address and the second octet of IP address is going to be used in full, because in the subnet mask all the 2 octets are turned on, so there's nothing to take away from there. But when we move on to the third octet in our subnet mask, we realize that not all bits are turned on. Hence, something has to be checked against the third octet in the IP address. So we are focusing on the third octet in the IP address and the third octet in the subnet mask. So let's compare these. So there it illustrates that the first 2 octets, the 192.168, those will be part of our network ID, but now we do not know which one will be part of our network ID from the third octet to the fourth octet. So now let's convert the fourth octet of the IP address, which is that 40. We convert the 40 into binary, so that's the one you see there. And then we also bring in the subnet mask third octet again. The third octet in our subnet mask is 248. So now the 2 are there. So what will determine our network ID is the level at which our subnet mask is turned on. Which ones are turned on? So the ones that are turned on in our subnet mask are the first 5 bits counting from left to right. Now when we come to our network IP address, we have 00101. When we circle or we single out these 2 based on the comparison, you notice that the 00101 is falling within the 10 bits of our subnet mask, meaning that this 40, remember that the third octet there is 40 and this one is 248, so this 40 is falling within our subnet mask, meaning that it must be used. The 40 will also be part of our network ID. But what about the 55? If you check our subnet mask there, it says 255.255.248.0. So that 55 is not going to mean anything because it will be 00000. Hence, our network ID is going to be 192.168.40.0. That 55 is not going to be considered because its subnet mask is .0. Wow, that's something new. But the beauty is this is a video, so you can pause, replay, keep on replaying as many times as possible for you to fully understand this. But if you don't get it, do not worry, we'll still have to go over it someday as we give more practical examples. So for today we end there, and that's the task for you. Find the subnet mask for this network ID 192.168.20.1/17. You have to get the subnet mask for that, given the CIDR. Now, given the subnet mask below, find its CIDR. Now it's the opposite. You have the subnet mask at 255.255.255.192. Find the CIDR, the classless interdomain routing for that. And then finally, using the mask at 255.255.255.192, find the network ID for this IP address 192.168.45.55. If you will be able to get these questions right, then it means you have done the right thing, and then it shows that you have fully understood this particular topic. So for me to know that you've worked on this, please inbox me the answers to these 3 questions. I look forward to your answers. Please enjoy your lesson and enjoy watching this video. So for now, thank you so much, and I look forward to seeing you as we open the college late this month. Thank you so much. Have a good day.